Let's dive into the fascinating story of TON 618, one of the most incredible quasars known to us. TON 618 is a hyperluminous, broad absorption line, radio-loud quasar, and Lyman alpha blob located near the border of the constellations Canes Venatici and Coma Berenices. It sits at a mind-boggling distance of approximately 10.8 billion light-years from Earth and boasts one of the most massive black holes ever discovered, with a mass of around 40.7 billion solar masses. The journey of TON 618's discovery began long before quasars were even recognized. In a 1957 survey of faint blue stars far from the Milky Way's plane, it was first noted on photographic plates taken with the 0.7 Menschmidt telescope at the Tonantzintla Observatory in Mexico. Mexican astronomers Braulio Iriarte and Enrique Chavira listed it as entry number 618 in the Tonantzintla catalog, describing it as decidedly violet. The true nature of TON 618 became clearer in 1970, when a radio survey in Bologna, Italy, detected radio emissions from it, identifying it as a quasar. Marie-Helene Ulrich then obtained optical spectra at the McDonald Observatory, revealing emission lines typical of a quasar. From these high redshift lines, Ulrich deduced that TON 618 was extremely distant and one of the most luminous quasars known. As a quasar, TON 618 is believed to house an active galactic nucleus powered by a supermassive black hole consuming intensely hot gas and matter in an accretion disk. Given its observed redshift of 2.219, the light from TON 618 has traveled approximately 10.8 billion years to reach us. The central quasar's brilliance outshines its surrounding galaxy, making the galaxy itself invisible from Earth. With an absolute magnitude of 30.7, TON 618 shines with a luminosity equivalent to 140 trillion suns, making it one of the brightest objects in the known universe. TON 618's spectrum contains emission lines from cooler gas further out than the accretion disk in what's called the broadline region. By analyzing the brightness of the quasar radiation that lights up this region, astronomers can calculate the size of the broadline region. Researchers Schemmer and colleagues used NV and CIV emission lines to measure the widths of the ODH4 spectral line in 29 quasars, including TON 618, as a direct measure of their accretion rates and, consequently, the mass of their central black holes. The emission lines in TON 618's spectrum are unusually wide, indicating extremely fast-moving gas. The full width at half maximum FWHM of TON 618's emission lines is the largest among the 29 quasars studied, suggesting gas speeds of about 10,500 km/s, driven by a very strong gravitational force. This led to an estimated black hole mass of 66 billion solar masses, a mass higher than that of all the stars in the Milky Way, combined and 15,300 times more massive than Sagittarius Aquae, the Milky Way's central black hole. However, a more recent measurement in 2019 by G and colleagues, using the CIV emission line, found a lower relative velocity of the surrounding gas at 2,761 plus 423 km/s. This suggested a lower mass for the central black hole at 40.7 billion solar masses, still an extraordinarily massive black hole but lower than the previous estimate. With such an immense mass, TON 618 might even be classified under a proposed new category of ultramassive black holes. A black hole of this mass would have a Schwarzschild radius of 1,300 astronomical units, AU, which is more than 40 times the distance from Neptune to the Sun. This cosmic giant continues to intrigue and challenge our understanding of the universe, offering a glimpse into the extreme and wondrous phenomena that lie beyond our galaxy.